Hello students, in this video we'll see an example of how to solve a constant coefficient ordinary differential equation. Let's consider y triple prime plus y double prime minus 16y prime minus 16y equals 0, which we can write in our operator notation as d cubed plus d squared minus 16d minus 16 applied to y equals 0. Remember, our goal is to factor the left-hand side. What we can do is we can factor this by grouping. The left-hand side, I can take from the first two terms, I can pull out a d squared. And if I do so, I'm left with a d plus 1. From the second terms, I'll pull out a negative 16, and I'll have a d plus 1. All of this applied to y is equal to 0. Now these two terms on the left-hand side have a factor of d plus 1, so we pull out a d plus 1. And then I have a d squared minus 16 applied to y equals 0. Now this is a difference of two squares, so this will be d plus 1, and then d minus 4, d plus 4 applied to y is equal to 0. And now I have three distinct linear factors. So now what we can do is we can recall that d minus a applied to y equals 0 implies that y is equal to c1 e to the ax. And since I can cycle the order of these things, I can put either the d plus 4 first, the d minus 4, or the d plus 1 first. So these can occur in any order. So these factors can occur in any order. That's a fancy way of saying that the left-hand side is commutative with respect to each of the factors. So this fact, together with our basic ODE fact, tells us that the solution will be y equals c1 e to the negative x. That corresponds to this factor over here, plus c2. This factor over here will generate an e to the 4x, plus c3. This factor over here will generate an e to the negative 4x. And I have three linearly independent solutions of my problem, and therefore we have found the general solution. Thank you very much.